We are covering Trig Unit 4, Day 3, graphs of sine and cosine with phase shifts. This is the trickiest day of this unit, so I'm going to define what a phase shift is, and then we're going to graph sine and cosine functions that have phase shifts. Phase shift is a horizontal shift, so we have vertical shifts up and down. Those are pretty easy to implement. Phase shifts are a little harder for a couple of reasons. First of all, because you can have two forms of your trig equation. You can have it in this form, y equals sine parenthesis. So I'm going to emphasize these because it's important. Bx plus c. So notice your b, or your horizontal stretch factor, is inside the parentheses. This will give you a phase shift of negative c over b. And just like our regular functions, quadratic and rational and radical, all the functions that we've had this year, whenever you have a horizontal shift, so x plus 2 squared is a horizontal shift to the left. So that's why this is going to be a shift to the left, and that is why we have this negative sign in front of the c. That's going to give us a left shift. And here's an example. Sine of 2x plus pi over 6. So our b is equal to 2. Our c, and our phase shift is our c, I should have mentioned that before. It's pi over 6. So our actual phase shift is going to be a negative pi over 6 divided by 2, which is equal to negative pi over 6 times the reciprocal of 2 over 1, which is going to be 1/2 negative pi over 12. And that will be our phase shift, and I'll show you how you're going to use that to transform our hash marks. But notice we will be working with a lot of fractions, and that's where the complexity, part of the other complexity of this. So as I said, this is a little complicated for a couple reasons. One is because we're going to be adding and subtracting fractions, and I know that's a little bit hard for people. The other is we can have this function written two ways. So here's the first one, and notice the difference. Here we have b inside the parentheses. Here we have b outside the parentheses. So if b is not inside the parentheses, your phase shift is simply negative c. You're not going to divide it by b. So that's a little bit tricky to remember, but it's important because else you'll get the wrong phase shift. So the example I have here, it's almost the same, except notice the 2 is outside instead of inside. So our phase shift is going to be a negative. It's going to be a negative of a negative pi over 6, which is a positive pi over 6, which is why we're going to the right. So if you have a negative in your equation in front of your phase shift, in front of your c, it gives you a phase shift to the right. If you have a positive in front of your c, it gives you a phase shift to the left. All right, let's look at some examples. 3 sine 3x plus pi over 2 minus 2. So we have an amplitude of 3, a vertical shift down 2. We have a horizontal stretch of 1/3. And then our c is pi over 2. And our phase shift, since this is inside the parentheses, it's going to be a negative c over b, which is a negative pi over 2 divided by 3, or negative pi over 6. So now we have all the factors. Now, how do we convert our hash marks? Well, we know how to do it for everything except this. And this is what it looks like. So it looks just like we did yesterday before we had the c. The only thing is, after we multiply our x by our 1 over b, we're going to add our phase shift, which in this case is adding a negative pi over 6 or subtracting pi over 6. So this is the part that causes people a lot of grief, because we have to, when you add or subtract, you have to have common denominators, and it can get a little tricky. So let me go through this one a little bit in detail. 2 pi, negative 2 pi times 1/3 is going to give you I'll do it over here, negative 2 pi over 3, and then we're subtracting pi over 6. We have to have a common denominator, so in order to make this 6, I'm going to multiply this by 2 over 2. So that's going to be negative 4 pi over 6 minus pi over 6. So negative 4 minus 1 is going to be a negative pi over 6. So that's how we get that. And then 3 times 0 minus 2. Here we're going to have a negative 3 pi over 2 times 1/3. That gives us, again, I'll do a couple. Well, actually, let me do this. I'll do each one right here. So that gives me negative 3 pi over 2 times 1/3, which is going to be, if I cancel these out, it's just going to be negative pi. Whoops. It's really not very legible. Negative 3 pi over 2 times 1/3. Actually, I'm just going to go ahead and multiply across the top and bottom. That gives me negative 3 pi over 6 minus pi over 6. So now I have the common denominator, so I don't have to make one. Negative 3 minus 1 is going to be negative 4 pi over 6, and I can divide a 2 out of both of these, and that's where I get the negative 2 pi over 3. All right, next one. So negative pi over 1 times 1/3 gives me negative pi over 3 minus pi over 6. So if I multiply top and bottom by 2, I get negative 2 pi over 6 minus pi over 6. Negative 2 minus 1 is negative 3 pi over 6. I can divide a 3 out of both of those, and that's where I get my negative pi over 2. All right, next one. Negative pi over 2 times 1/3 is going to be negative pi over 6 minus pi over 6. So I have a negative 1 pi minus negative 1 minus 1 pi is negative 2 pi over 6. I can divide a 2 out of the 2 and the 6 to get negative pi over 3. And this just becomes 0. Minus pi over 6 is just negative pi over 6. Pi over 2 times 1/3 is pi over 6 minus pi over 6. A positive pi over 6 minus a negative pi over 6 becomes our 0. And then pi times 1/3 equals pi over 3 minus pi over 6. This becomes 2 pi over 6 minus pi over 6. So 2 minus 1 is just 1 pi over 6. And if you notice the pattern, you can probably guess this one's going to be pi over 3 because it is symmetric. And then the next one's going to be 2 pi over 3. Whoops, sorry, pi over 2. And then that's it, actually. So one thing we notice here, we've got 1, 2, 3, 4, 5 on the negative side and only 3, and I should be doing it over here because I'm looking at the x-coordinate. So I have 5 negative x-coordinates and 3 positive, so we're going to make our axis a little bit different. So if these are our hash marks, so notice how I've kind of skewed the x-axis over. So I need 5 over here. 1, 2, 3, 4, 5, and 3. Is it 3? No, just 2. Oh, it's off the map again. And then I need 3 over here. And I'm going, and these are, if you haven't noticed, these are actually, we're adding pi over 6 to each one of these. So it's just negative 5 pi over 6, negative 2 pi over 3, negative pi over 2, negative pi over 3, negative pi over 6, and then pi over 6, pi over 3, pi over 2. And we're going from negative 5 to 1. So 1, 2, 3, 4, 5. All right, so if we graph, now we're going to graph pi over 2. All right, so the one we're missing is pi over 2. Whoops. Pi over 2, negative 2. All right, so here we have a point here at -2, a point here at 1, a point here at -2, a point here at -5, -2, 1, -2, -5, -2, and that's our sine curve. So we're going to find the same things we did before. Our y-intercept, fortunately, is there. We have to use trace to get our x-intercepts. Our mins are at -5, so we've got those two mins. Our max is at 1. Whoops, and sorry, this should be 2 pi over 3. Is that right? No, yeah, -2 pi over 3. Amplitude is 3, is that right? Yes. Vertical shift down 2. Vertical stretch of 3, no flips, period, again. So it's going to be 2 pi over our b. So that's how we got this horizontal stretch of 1/3. And our phase shift, pi over 6 to the left. Actually, is that right? Yes. So it's pi over 6 to the left. All right, next example. -3 cosine 2x minus pi over 3 minus 2. So notice our b is outside the parentheses. So we have an amplitude of 3, gives us a vertical stretch of 3. We go down 2, vertical shift down 2. We have a b of 2 giving us a horizontal stretch of 1/2. Also, we have a flip over the x-axis. And then our phase shift is going to be pi over 3. Our c is pi over 3. And since this is outside the parentheses, our phase shift is going to be negative pi over 3, or positive pi over 3 to the right. So we're going to multiply our x by 1/2 and then add pi over 3, multiply our y by -3 and subtract 2. So this is just giving us -2 pi times 1/2 is negative pi plus pi over 3. So -2 pi is going to be, negative pi is going to be 3 pi over negative 3 pi over 3 plus pi over 3. So a -3 plus 1 is a -2 pi over 3. I won't go through this in as much detail. This is 3 pi over 4. Common denominator of 4 and 3 is 12. So we're going to end up with -9/12 plus 4/12, which gives us -5 pi 12. Pi over 2 times 3, common denominator is 6. So we have -3/6 plus 2/6, which gives us a negative pi over 6. This becomes negative pi. So this is -3 pi plus pi. Is that right? No, this is negative pi over 4 again. Common denominator is 12. So we've got 3 pi over 12. -3 plus positive is going to give us a positive pi over 12. And then so on. I'll show you the hash marks, and if you have questions about them, you can ask. So notice in our graphing how many negatives. We only have 3 negatives and then 6 positives. We don't have anything. We don't have anything at the origin, so we don't have a point at x equals 0. So when we graph this, we have to take that into account. So we're going to have, how many is it? 3? Okay, 1, 2, 3, and then we want something, actually let me do that. So we're at 6, 1, 2, 3, and then we'll do 1, 2, 3, 4, 5, 6. So notice this is closer. The spacing is between these two, not each of these on the y-axis, because we don't have a point at 0. All right, so we have -2 pi over 3, -5 pi over 12, -pi over 6, pi over 12, pi over 3, 7 pi over 12, 5 pi over 6, 13 pi over 12, and then 4 pi over 3. Min is -5, max is 1. Again, 1, 2, 3, 4, 5, 1, 2. And if we plot our points, this is going to be -5, -2, 1, -5. Is that right? -2, 1, -2. Whoops, I'm off one. Am I missing one? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. So 5, 2, 1. Whoops, that's the one. So this one should be, this is actually -2 here, then -5, then -2, then 1, -2, -5. So you can see it is a flipped over cosine curve. That one's a little too deep. And again, key characteristics, y int, we actually had to use, we didn't have one in our hash marks, so we had to use a graphing calculator to find that, as well as our x-intercepts. Our mins are at -5, max is at 1, amplitude of 3, vertical stretch of 3. This should be down 2. We did have a flip over the x-axis. Our period is 2 pi over 1/2, which is going to be 4 pi. And that's actually not right, is it? Our period, we actually had a 2, so it's going to be, our period is going to be 2 pi over 2, which is going to be pi. And we have pi over 3 to the right is our phase shift, horizontal stretch of 1/2. Okay, I think the last thing, so now I'm going to summarize. These are all the changes we're going to be looking at for our function, so I'm just summarizing them. So if you have a function of this form, what do these things define? What changes? Well, A is your amplitude, which is max minus min times 1/2, or divided by 2. It's also your vertical stretch, or smush. So you're multiplying your y value by A. A negative A means you're flipping it over the x-axis, and you're going to multiply your y by -A. B changes the period. The new period is, whoops, I need to update these, 2 pi over B. This is your horizontal stretch. And then we want to, you have to multiply the x-coordinate by 1 over b. A negative b is a flip over the y-axis. C is a phase shift. It causes a horizontal shift. So in this one, b is outside the parentheses. So that means you're going to, your phase shift is just going to be a -c. So phase shift equals -c. And d is your vertical shift. Add to the y-coordinate, moves you up and down. All right, so if you have a function of this form where b is inside the parentheses, all of these are the same. This is what is different. You have a phase shift of -c over b. So you're going to have a -c over b that you add to your x-coordinate here. Here you're going to add a negative of a -c over b, which is just going to be adding c over b. But the important thing is your phase shift now is not just c, it's c over b. And then another final summary. This is how you convert the hash marks. If you have this form of the equation with b outside, it's going to be x times 1 over b minus c, and then y times a plus d. If you have the b inside, it's going to be x times 1 over b minus c over b, and then y times a plus d. Whoops. You probably already saw that, but you probably want to try and see if you can convert these, or convert the hash marks for this function, and then check, because this is probably the hardest part of this unit. Other than that, you will have a worksheet for homework. Please bring questions to class.